Next question, question number 3, it asks about plant and about process in the plant. So it's good that you can tell on the order of the pathway of how water is carried inside a plant here. So nothing else to add it here. The second question is asking about the process when the plants lose water from the surface of their leaves. So it's not respiration, but it's transpiration. Okay, what's the difference between respiration and transpiration? Respiration will also produce the water. Yes, I agree. And another thing that's important, that's CO2, so it will be CO2 and water vapor, but it will be at the cell. It's kind of like process, a cellular process. So usually it at like the cell level. Here we're talking about like the whole trees, and especially when the water leaves out at the leaves at the surface. So the name of it is transpiration. Okay. Then C, the question C here, yeah, you got it right. Decreases. Okay. Yeah. So nothing else to add for this question. Oh, by the way, just want to add it here in the mark scheme. They said that if you just mention the process as diffusion, you don't get the point. Okay. Sweating is not accepted as well because sweating is not applicable for plant. Okay, sweating is for some animal with the skin, just like human. Okay, so don't use the word sweating, but it should be transpiration. Okay, and here for the question C, if you mention like they die and cannot grow or become extinct, it would not be accepted. It just decreases is good enough. Okay. Yes, and that's question number 3. Move on, question number 4. You got it right. Good. And here for the C. So whenever they give you two waveform, a waveform A, a waveform B, and then you add them together. Remember last time I showed you, right? Just remember that you can just pick any point. For example, if this is the how the particle at this position is moving. Then for A, you can see that it being displayed away by 2 units right here, right? And here it should also be displayed by 2 units. So if you add the displacement at this position, let's say it's a P point, you got it's like 2 plus 2. That's why you got it to be like 4, right? This is the 1, 2, 3, 4. So see that they add it together and they make it greater compared to the component. Like compared to A, it's just like 2. Compared to B, it's just like 2. This is like 4, right? So that's why it's greater, and we said this is reinforced, right? Whenever you have it increasing, the displacement increasing, that will be reinforced. What about at 3 seconds? Oh, my bad. It's to mention here that this is 1 second. Oh yeah, it's good that we pick this random value at the 1 second as well. So that is good. What about the 3? This is the 3 position. At the 3 here is actually like 2 displacement, but in the downward here, right? So minus 2 here, and this is like plus 2 here. So if it's plus 2, minus 2, then the signal here just cancel each other, right? Imagine like if you standing at this point, there's a signal from A coming and ask you, hey, jump up for 2 units. Then you try to jump up, but then there's another signal from B say like, hey, no, you have to like sit down for 2 units. Then you have to follow both of them. Okay, that's the rule. So that's why you have to either up 2 and then downward 2. That's why it just turned out that you cannot move at all. So that's just going to be like 0. And if they just like cancel each other like this, we say they cancel out each other. Like what, you have the little letters here cancel out. So that's good. That's why reinforce and cancel out. Okay, so that's all for the question related to wave. Coming carbon cycle. You got it everything right. I don't have anything else to add except here when you mention about the similarity between the combustion and decomposition, you say release gas. Yeah, but what kind of gas? Because if you just mention gas, it could be like oxygen, it could be nitrogen, it could be many different kinds of gas. So here to make it more specific, you just mention carbon dioxide, okay? Yeah. Let's have a look at their mass scheme. See, they also mention carbon dioxide or release heat, or if it's releasing heat, then it should be exothermic reactions. But you mentioned this one is good enough, okay? I don't think that you focus too much on the exothermic reaction and the heats in your program, so carbon dioxide is good enough. And here, if you just mention they are both part of the carbon cycle, then it's so obvious, right? Then you don't get the point if you just mention something too obvious, too easy to know already. Or if you just mention that the breakdown of carbon, it also means that the same thing, so you would not receive the mark if you just mention like this. And if you just mention release carbon, that is not good enough. It release the gas, okay? And basically this should be the CO2 gas. So here I'm kind of being strict on you a little bit. I don't give mark for this one, just to remind you that remember gas, which is carbon dioxide, okay? That's the important thing. And it's also here in the diagram itself. You see that? See? So I told you, usually you can find the answer or like the hint from the problem statement. And yeah, so therefore the carbon cycle. Let's move on to question number 6. Okay. The thing is that I think that you know the trend, the pattern in the table already. Like you mentioned, as we go down the group 1, we know that going down means like from lithium to sodium to potassium and to rubidium. How do we know? Again, there's a periodic table at the end, okay? Lithium, sodium, potassium, rubidium. So we're going down in this order, right? Okay, let's get back to that page here. And they ask for what? They ask for the trend in atomic radius. So, you mentioned melting point decreases. I agree. Yes, I can see it's decreasing. It's dropped by 83. It's dropped by 34. But what happened to the atomic radius? They going up, right? They're increasing. You see it? It's just such a quick crack that you missing the point for this question, right? Just need to mention atomic increasing, okay? Oh, by the way, for the last question, number 5, have a look, check it yourself at the mark scheme again, just to see if you mention just the ozone or ozone deflection, you don't get the point. If you just ignore weather change in very general idea like this, you don't get the point, okay? And if you just mention like ice melt or snow melt, and it will be not good enough to get the point. But you can mention either two out of these, and that's what you mentioned. You mentioned the sea levels, you mentioned about the drought, so that should be good enough, okay? So anyway, just check the math scheme again. Okay, let's get back to number 6 here. So again, atomic radius increases, that's what you need, okay? And here predict the melting point of rubidium. From the math scheme, it said that you should have the range from 20 to 45 degrees Celsius. I mean, for me, to be honest, I think that you have a good guess already. Why? Because you can tell that it should be decreases. So it should be some value that less than 64, right? So how come we know that it should be something like within the range of even 45 but not 57? To me, I don't have a really solid reasoning for it to be from 20 to 45 here, to be honest. I just can tell that, okay, if we see the trend, you can see that as the atomic radius increases, you can see that the nucleus here and the electrons just become like further far away from the atomic radius, right? Like this is the atomic and this is the electron travel around. the electron on the outermost shell will define the atomic radius. So if they're pretty far away, it also means that the interaction between them will be less. That's why it doesn't require a lot of energy to break the bond. And that's why it can changing the phase more easily, and that's why the melting point just like lower. So the mechanism behind the scene is that what it can be explained that way. And the other way we can see is that if this one, the atomic radius as this one increases, you can see that the melting point that decreases, they are like have an inverse relationship. So you can see that also the change in here. It changed from like 40 and now it changed to like 15. So I could say that here, the change here to drop here, it should be less than 30. So a good guess is that it could be like drops to like 20 degree Celsius. That's why it can drop pretty like the highest it can drop to like 45. That's why they mentioned it can be like either 20 to 45. Because why 20? Because actually at the normal temperature, the room temperature, rubidium should be in the solid phase, right? So it cannot be like liquid at that time. If the melting point is something like pretty higher than 25 degrees Celsius at the room temperature, then rubidium should be like liquid at the room temperature already. So that should be somewhere high. But I could say that not very a solid reasoning. So I could say maybe the teachers like to remember, it's kind of like a fact to learn with elements. So if they happen to ask you some question like this again, I could say we don't need to pay attention too much for it because it's just like one mark. But the logic, the reasoning is that way. And you can see that if you just drop from 64 to 57, it's just like about 7 degrees Celsius. That's not very much the change. Maybe it should be 20 degrees Celsius. Okay? Okay. Drop by 20 degrees Celsius. So it should be somewhere within that range from 20 to 45 degrees Celsius. And I could say even should be more higher than 20, like 25 to 40 degrees Celsius. Okay. And again here, for the C, here, did you notice this? They are ionic structure, yes, and the temperature. 808 degrees Celsius. Can you imagine how hot it is, right? Even the boiling water at 100 degrees Celsius is really hot already. This is like 808 degrees Celsius. So in order to burn, I mean not like to burn, but like to breaking on the bond between each molecules, it also requires a lot of energy. So if it's a very high energy like that, to just like breaking the bond to bring it from a solid phase to a liquid phase, it should be a big giant structure, right? It's just like a lot of bond to break. That's what it means, It's just like a lot of strong bonds to break. That's why it should be a giant structure. If you just mention the lattice, it does not help. It's not that helpful. Why? Because lattice structure is also lithium, it's also sodium, it's also potassium, it's also rubidium. Lattice is basically the very basic structure for solid. So if you mention the word lattice, it does not count. If you mention ionic, then yes, but the important thing is that you should have the word giant, okay? Giant is the keyword to earn this 1 point. Okay, so that's about chemistry again. And then for question 7, this is just like to remember on the symbol of the electrical symbols, and I believe that in the syllabus they list out for you, I think that maybe up to only 12 symbols to remember, right? So this is pretty good. You had it right. Just a little mistake in the spelling, resistor, okay? Like doctor, not like sister, okay? Resistor. Yeah, so that's for question 3, 4, 5, 6, and 7. Okay, and then we will keep moving in the next video. Thank you. Please let me know if you have any question.